Hey, Professor Caps, this is Michael James recording my Alka-Seltzer reaction video. So I've went ahead and prepared a couple of the components of this lab already to kill some time. I want you to see this right here. So this is a water bottle with about 25% full by volume of water, and then about another 50% full by volume of your standard cooking vegetable oil. And then if you can see at the bottom, I've dropped in a couple drops of blue food coloring. All right, so I'm going to go ahead and start this reaction, and then I'll go through and kind of define what happened and explain a couple things. So here is my Alka-Seltzer tab. I'm going to break it up so that I can fit it into the bottle. And then I will let you watch the reaction with me. Cool. There we go. I'm going to go ahead and cap this. And I don't know if you can see that or how well you, well, it looks really cool. So, looks like it took a couple seconds to get the reaction started, but now it's rolling nicely. If you can see, it looks like, well, I'll explain this later, but I know that carbon dioxide is the cause for the fizz, and you'll see it coming up the side to the surface, and then looks like something's dropping back down towards the surface of the oil. Oh, looks like our reaction has stopped. Just forget, oh wow. When I opened the bottle, there was a release of pressure, so I guess that was the buildup of carbon dioxide. All right, so I'm going to roll through what happened now. So there are two types of changes. I think it's important to discuss these first. A physical change is when there is a change in the look or shape of a substance, but it does not make a new substance. So therefore, no chemical bonds break or form. So a good example of a physical change is when paper is crumpled or torn. So the look of the paper will change, but it's still paper. So the other type of change is a chemical change, and this occurs when new substances are produced. So in a chemical change, bonds are broken and new bonds form. So using the same example as paper, when paper is burned, a chemical change occurs. So in our lab here, the Alka-Seltzer tabs are commonly used to treat indigestion. The tablet is made of both an acid and a base. So acids are molecules that can donate small charged particles, which are also known as hydrogen ions. So bases are the opposite of acids, and they accept these hydrogen ions. So when acids and bases come into contact with each other, they're going to create a chemical reaction. So the Alka-Seltzer tablet is composed of both an acid and a base, but they're in solid form. So when in the solid form, there's no chemical reaction because the molecules don't move. However, when they enter water, the chemicals are released and they can react with each other. So when I dropped the Alka-Seltzer tablet into the bottle of oil and water, a chemical reaction occurred, and carbon dioxide bubbles were released. The fizziness happened when sodium bicarbonate, which is also known as baking soda, and citric acid react chemically in water. The products of this reaction are sodium citrate, water, and carbon dioxide gas. So in a chemical reaction there are reactants, and they yield products. So the packaging of our Alka-Seltzer tablet contained 325 milligrams of aspirin, 1,000 milligrams of citric acid, and about 1,900 milligrams of sodium bicarbonate. So I did a calculation and found out that there are only 17.4 millimoles of the hydrogen ions, which is not enough to neutralize all of the sodium bicarbonate, which is, by my calculations, 22.8 millimoles. So thus, the citric acid, in this case, is the limiting reactant. All right, thank you.